Good evening. Right, so we'll go through the past papers, the MCQs first, okay? So we are going to go in through the past papers of the computer networks, okay? Right, so we'll start with the latest available. So basically, the latest available is 2023 paper one. Okay, so then we'll move on to 2022 and backward, okay? Right, so I'm not going to do any revision or whatever because you have the recordings. Okay. But when I do some questions, maybe I will explain a little bit of things. Okay. Right. So the best thing is do at least 2 years of past papers and then continue your study. Okay. So then you know what are the examiner's favorite areas and so on. Okay. And otherwise you spend a lot of unnecessary time memorizing things that the examiner is not interested. Okay. Right. So the question number one. What is the protocol data unit of transport layer? So remember in OSI architecture, say physical, logical link, then network, transport, then of course session presentation and application. So here data unit is bits, physical layer bits, uh, logical link layer it's frame, data frame. Network layer, it is data packet or datagram or IP packet. And transport layer, it is segment. Segment. So the protocol data unit is segment. And above, there's nothing called protocol data unit because they are interested in as application as a whole. So therefore, the answer must be E. Let me open the answer sheet. Right, answer is E. Right, so we'll do faster. Second question. In OSI model, which layer is responsible for ensuring process-to-process data delivery? Remember the two processors from this machine to other machine. So these processors are identified by port number. So the process-to-process delivery is not something to do with physical, logical link or network, but it is process-to-process communication start from transport layer. That is why we have port number to identify the process. Right. So therefore, obvious the answer is transport layer. We have discussed those. Right. Question number 3. What is the size of fixed header transmission control protocol data unit uh, protocol TCP protocol data unit? Right. What is the size of the header in TCP? So we discussed the TCP header size. UDP header size. Of course, UDP header size is small, TCP header size is big. Okay. What was the exact value? I can't remember exactly. Definitely, it must be in your note. Okay. So let me open the note. I can't remember the exact value. It should be in your transport layer concepts. Right. UDP header is 8 byte. Right. 8 byte. But TCP must be then bigger than that. Right. 32 bit, right? Right. 20 byte to 60 byte variable length. Minimum 20 byte, maximum 60 byte. Do we have something like that as answer? TCP header. And minimum is 20 byte. Maximum is 60 bytes, so we'll go for the minimum value. So the answer is C. Yes, answer is C. So examiner has taken the minimum value because it's 20 to 60. The minimum is 20. This is a very easy question. Rank the following transmission media in order of their bandwidth, starting from lowest and ending with the highest. So the lowest bandwidth, okay, the lowest bandwidth must be twisted pair, then coaxial, then fiber. So the answer must be B, right? Fourth one answer must be B. Easy questions, okay? Fifth one. Which DNS resource record type specifies the servers responsible for receiving emails for a particular domain? What is the email related DNS entry? MX entry. So we discussed that. DNS entry for email related things is MX entry. So the answer must be C. Sixth question. What is the flag need to be sent to immediately send the segment of the network layer in transmission control protocol? What is the flag need to be sent to immediately send the segment layer to the network layer? So remember then that is not acknowledgement. Reset is reset in the communication. This is synchronizing. So these are the two candidates, push, urgent. So both are used to speed up. Both are used to speed up. But one needs to speed up the overall. The other one needs to speed up only that part, that particular part. Okay. So there's a small difference between push and urgent. Okay. So I can't remember exactly which one. Possibly push. Okay. So let's open the note. Transport layer. Yeah, again transport layer. Right, this one. So urgent immediately give the portion of data to the application layer. Push, if the flag is set immediately, the data segment as a whole will send to the network layer. So this is as a whole. This is just that particular part of the data. Okay. Uh, so therefore, it's a little bit confusing which one is the correct answer. Definitely either urgent or push. Urgent or push. I'm not very sure which one. Anyway, this paper says only one answer is correct. Right? Only one correct answer. Always double check instructions because this year it can be different. Paper by paper, you need to double check. Okay. Right. Possibly, I'm not very sure. Maybe push. Okay. Six. Yes, they have taken push. ESH. Right. Anyway, it's a little bit fussy whether push or urgent according to the instruction because both are to speed up. Okay. Seven. Which component of the software defined networks? That is, I think, our last one of the last topic. Architecture facilitate the programming of the network behavior through the controller. And now, to answer this, you must remember understand the SDN architecture. Right? SDN architecture. So then only you can answer this. Right? Software defined networks. You can refer to the UCSC notes as well. Right? So remember the lower level we have hardware, but more programmatic things are done by upper layers. Right? So this is traditional. Traditional, we had data plane, control plane, and management plane, right? But new approach, right? New approach. So getting the control from the hardware to the software. because software layer is, though it's little bit less performing, it's more flexible. Okay. Right. So basically, software applications are plugged into the northbound API and southbound API, right? Yeah. So your applications are pretty much bound to the northbound upper layer. Low level things are bound to the southbound. But applications are like different language modules uh, bound more into the northbound. Okay. So in between we have the modules. Low level software, high level applications. So should I go for northbound or southbound? So high level things are northbound, right? Not data plane and those things because software is related to the APIs, right? APIs. Maybe I'll go for the northbound API because that is more application software, application, right? Like routing and so on. I don't know. Let's check the answer. Seventh one. Right. So examiner has taken both D and E as answers. That means because only one answer is correct, that means definitely if you mark D, you must get full marks. If you mark E, you must get full mark. Is it mentioned? Yes. Okay. But if both are selected, no marks are given because exam question says only one correct answer. But those who mark D has given full marks. Those who mark E also has given full mark. That is fair because software southbound also you have a bit of software, right? But better to go for northbound. Right. Eight. Which of the following communication models best describe the network topology formed by Bluetooth devices? Now, we discussed topologies for local area network like star, bus, ring. Of course, ring is very rarely used these days. Then we look at topologies for a wide area network like tree, mesh, but we did not discuss topologies specifically for Bluetooth, right? So basically, why we did not discuss specifically Bluetooth because mostly Bluetooth is just connecting one machine to the other machine. No, okay. Say this smartphone connected to this smartphone, and there's a possibility of another smartphone connecting to this. That means two Bluetooth devices are connected to this. So therefore, it is not definitely something like publisher subscriber, can't be client server also, or how do you call it? So that is a little bit not, I don't think it is mentioned in your note also, but anyway, it's a good question, right? How do you call it? Shall we call this master and these guys slaves? I'm not very sure about that. Okay. Because it's a very casual way of just connecting, right? At one time, this can X connect to Y, at sometimes Y connect to X. It's sort of mutual understanding, right? I don't know. I'm not very sure about that. Okay. What is the examiner's answer? Examiner has taken master and slave. Yeah, maybe this is master. Others are connected to that one. So we call them slaves. Just make a note of that. Okay. So that is not in, I don't think that is mentioned in your note. Okay. That is not mentioned in your note. But examiner has taken the answer as master slave. Okay. That can be there, right? Otherwise, everyone will get 100 out of 100 and A pluses. Okay. Just give 1 minute. Okay. Right. So let's continue. So the examiner has taken it as master slave, right? So we'll go by examiner's answer. Just make a note of that. Right. Ninth question. What is mean by byte stuffing used in data link layer? What is that? Has it mentioned anything like that in data link layer? Okay, let me open your. I don't think it's mentioned in our note, but maybe UCSC note. It says which layer? Data link layer. So then it should be in the data link layer note, right? I can't remember such word. Maybe in your reference book. Nothing with stuff. Maybe byte. That is normal byte. Right. Just double check whether they have mentioned anything like that. Okay, I can't remember actually. Okay, what is byte stuffing? Maybe in your reference book, right? I'm not very sure about what is that. Okay. By the way, what is the exact answer given in the answer sheet? Ninth one. D. Byte stuffing refers to inserting an escape byte before flag bytes inside the data. I don't know what is that. Maybe a very special thing. Let's see whether they have mentioned something like that in the flag. Not mention something like that also. Anyway, I'm not very sure about that. Okay. Maybe just to isolate or separate the flags. Like inserting an escape byte before flag bytes. Maybe just to mark that it is now you are into the flags, right? Maybe something like that. Okay. Anyway, nothing like that we discussed, right? Data link layer. Let me again double check with our notes. Data link layer concepts. I don't think that we have discussed anything like that. Do we have something like that here? No, we haven't discussed. Maybe again from your reference book or maybe examiner just want to make it tough question. Okay. Don't worry. You don't have a lot of that kind of question, right? Right. So the next question, 10th. What advantages do hardware routing tables offer compared to software-based routing tables? So remember, when it comes to hardware, it is faster, but not flexible. When it comes software, it is flexible but not fast. So that is a big difference, right? So now that is the basic idea behind hardware routing table and software routing table. Okay, right. So see whether we can get something like that. Keep high-speed links and to route packets at the link speed. That means high speed link means you can do the routing fast. Do they talk about hardware routing? Yeah, hardware routing tables compared to software routing table. Yes, so when it comes to hardware routing table, it's super fast. Only thing is it's not flexible. Okay. Increase maintainability. So usually software is maintainable because soft enable to configure from central point. So configuration and those things are easier when we do use software. That is why we go for software control networks. Possible to enforce policies centrally to the network. Now, all these control policies, flexibilities coming from software. Ability to see in the entire network at once. So those kind of things, right? High control and those things are with software. So the advantage of hardware is high speed, right? High speed because it's hardware level. You don't need to come to the software level and again go back because your data is transmitted at hardware. So therefore it should be A. Okay, it should be A. Yes, answer is A. Right, 11th question. This is an interesting question, challenging question. Answer question 11 to 20. You can see almost 10 questions based on the following network diagram. Therefore, read the question because this is related to 10 questions, right? Device R1 is a router. Where is R1? Yeah, this is your router. And SW1 and SW2 are switches, right? So these are switches. PC0 and PC1 has only wired network interface. So that means wired PC0 and PC1. So that means wired Ethernet. Okay. Wired. All the devices are connected using cables. So except the connection between smartphone and access point. So that means these are all cables. All cables. But this is obviously wireless. Okay, wireless. Take your time and read it because it's worth. Because 10 questions. Right, question number 1. So basically this is one subnetwork. This is the other subnetwork. That is why we need a router and connected by router. And router has two IP addresses facing two interfaces. And there's a DHCP server here. But here no DHCP server, but there's a web server and one machine. Okay. So possibly that means IP address must be statically configured because no DHCP server. But here dynamically you get the IP addresses. Right. So let's take one by one. What is the data link layer protocol that can use between PC0 and SW1? PC0 and SW1 data link layer protocol. Right. UDP is not data link layer. UDP is transport. IEEE 80211 is that is Wi-Fi. So Wi-Fi cannot be used for wired connection. TCP is not data link layer, that is transport. IP is network layer. Yes, Ethernet is the data link layer concepts, right? Data link layer concepts. How the frames are sent, like Ethernet, if you use star or bus topology. But if you go for something like ring topology, Ethernet is not used, rather token ring is used. Okay. But if it is wireless, neither Ethernet nor token ring, it's some other technologies like IEEE 802.11, that is Wi-Fi. Or Bluetooth if it is normal PAN. So therefore answer must be what? Ethernet. 11, yes, Ethernet. 12. What is the data link layer protocol that can be used to communicate between smartphone and the access point? And obviously, IEEE 802.11, that is Wi-Fi. 12, yes, D. 13. Which of the following IP address can be used as default gateway of the PC0? PC0. So PC0 is this one. PC0 is this one. So basically default gateway is if you don't know where to send that data packet, you send to the default gateway. Default gateway is usually you are going out to the out of your network, because if it is inside thing, you must know the IP address or MAC address. So basically, default gateway is basically your your router, your router, your router's IP address or your router's local IP address. Okay. So therefore, for this one, your router is this. Because from there you can go out, maybe connect to internet or whatever. So therefore, this one's default gateway, not only this one, all these devices default gateway must be this. Right? Because router has two IP address. For this side, because IP address is configured in your network interface card, and this is for this part. So therefore, I'll go 192.168.10.1 of course /24 is subnet mask. 192.168.10.1, because that is your router's IP address, your site's IP address. I'll go for B. Yes. 14. What is the transport layer protocol used by PC0 when requesting website from the web server? Right. PC0 requesting a website. Requesting a website means HTTP. With HTTP, the transport layer we use is TCP. Right? Mostly TCP, right? Very rarely UDP like DNS, real-time uh, data streaming and so on, right? Otherwise, it's almost all the time transport layer is TCP, protocol is TCP, like HTTP, email, file transfer. Always we go for TCP. That is the easy question, right? 14. Yes, B. 15. What is the application layer protocol used by PC0 when requesting website? So that is kid stuff, right? If it is web server, HTTP. Right? 15A, yes. 16. What should be the destination IP address included in the packet created by PC0 when requesting a website from the website from the web server? So that means this one's IP address, right? Assuming this is public IP address, right? Assuming this is public IP address, so your data packet must go towards this. And they have not mentioned whether it's public or private. I think 10 is private or public. Right? But I'll go for 10.0.0.10, because that is the IP address of that. Okay? Because destination IP address must be there, right? Because the data packet. I'll go for C. Yes, C. What is the protocol used by PC1 to discover MAC address of the web server? PC1 to find the MAC address. Yeah, if you are interested in MAC address, it must be in your side, right? Because this guy is not interested in MAC address of web server, because two different. MAC address is used only within your network. So yeah, that is fine, because PC1 is uh, in the same connected to same switch as web server. So which protocol? Which protocol? OSPF is a routing net protocol. Right? Is it address resolution protocol or DHCP? It should be maybe one of these, DHCP or ARP. DHCP usually, no, sorry, not DHCP, right? Is it ARP? I think ARP, because ARP help you identify MAC address given IP and IP address given MAC. Right? So shall we double check that? ARP, discuss. Maybe network layer. Right. Address resolution protocol. Resolve MAC address to IP, IP address to MAC, both. Other one is reverse ARP. Reverse ARP. DHCP is to give IP addresses to the machine, right? Not resolution, right? So therefore, I'll go for ARP, possibly ARP. Right, I'll go for it. 17, yes, C. Because DHCP is to assign IP addresses. It is not going to give you resolve your MAC address to IP address. ARP is the one that resolve IP to MAC and MAC to IP. Okay. Right, 18. Assume that smartphone is just connected to Wi-Fi network and needs IP configuration. What message does the smartphone should broadcast to locate the DHCP server? We discussed that. To locate the DHCP server, you need to send the discover message. So then you make a request, then you get an offer, and then you need to acknowledge. I think synchronization must also happen somewhere. I can't remember. Okay. Anyway, we discussed that. So answer must be discover, right? First thing must be discover. Is it discover or synchronize? If I can remember, it must be discover. Okay. 18. Yes, say. So let's double check that in our note. Network layer. And you can see IP address request, IP address offer, uh, then the acknowledgement. Okay. Acknowledgement. Right. I don't think there's something called synchronize. Right. Request, offer, but in our note I have not mentioned about the discover, right? That is bad. Maybe it's mentioned in your UCSC note. I can remember somewhere it was mentioned. Let me double check that. That is why I asked you to refer to both, okay? Because this one has more details about that. You can see address resolution protocol. Internet working, router, right? Interdomain versus intradomain, IPv4 format, IPv6 structure. Subnetting we did, okay. Make sure you refer both, right? Network address translation we discuss. Where is this? These are routing protocols. Yes. DHCP. Do we have something like that? It should be here. No, right? Maybe they are referring to the use. They are referring to the reference book. Okay, but it should be there. Should be a discover message. Okay, so let's ask from ChatGPT. Explain messages used in getting IP address from a DHCP server. Right, you can see DHCP discover, then DHCP offer, DHCP request. Of after offering only you request it, and acknowledgement. So server acknowledge that okay, you have been assigned. Okay, right. So just make a note of that. Okay, discover, offer, request, acknowledgement. Okay. Anyway, it was not mentioned in your UCSC note, therefore I haven't added it. But there's a image in our note, but it's not very detailed. Right? It is not very detailed because it doesn't have the discover. Okay, discover. That is the only issue. Maybe D DHCP messages image. I think this one is better. DHCP discover. You can see. Right, so this diagram is, I think, better. Yeah, DHCP discover, offer, request, acknowledgement. Maybe I should add that to our note also, rather than the old one. Because this doesn't have, discover is there, right? Sorry, DHCP discover is there. Sorry, I only, right, discover, offer, request, acknowledgement, right? Discover, uh, offer, request. No, this diagram is correct, right? Correct. I didn't see this. Can see DHCP discover. Yes, one is correct. Right. So therefore, the answer is discover. Anyway, our note has that. Right. 19th one. What should be the destination MAC address of the message broadcasted by smartphone to locate the DHCP server? So remember, in IP addresses, the broadcast IP address is the biggest one. Remember, when we create a subnetwork, we reserve two IP addresses. The smallest subnet ID, biggest broadcast ID. So always the biggest number is the broadcast ID, right? In MAC addresses, there's nothing called subnetting. MAC addresses are hard coded. Okay. So therefore, just make a note of that. I think this is not mentioned in our note, or maybe it's not mentioned in your UCSC note also. Uh, so just like we take the biggest number as the broadcast address in subnetwork, in MAC addresses, the biggest hard-coded value is considered as the broadcast. So when there's a data frame with largest MAC address, remember the smallest MAC address is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Remember this is vendor part, this is sequence number. And it's hexadecimal number. So therefore, what is the biggest you can go? FF, 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 FF. So that biggest number is considered as broadcast in any network. There's nothing called subnetting. So just make a note of that. Just like in IP addresses, we take the biggest number in that range as the broadcast. In hardware level, MAC address level, the broadcast, if you want to broadcast your data frame to each and every machine connected to the switch, you just send it to this address. So then your switch will broadcast it to each and every node connected, because then only you can get the response from DHCP server, right? Because still you don't know still you try to get an IP address, right? So therefore you need to broadcast. And then the DHCP server must respond to you because your MAC address is there in your message. Destination MAC address will be this. So then switch will broadcast. And if a DHCP server is connected, DHCP server will respond to you saying that I have this IP address. I offer this IP address. Then you need to request. Then it must be response. Acknowledge, saying that yes, confirm, you are assigned. So the answer is, just make a note of that. Broadcast address is the biggest MAC address. That is, answer is C. Right. Which one is that? 90. Yes, answer is C. 20. Assume that the smartphone has received IP configuration from DHCP server. Right now, the smartphone has got the IP configuration. That means maybe IP address from the DHCP server. Right, IP address from DHCP server. Yes, DHCP server has sent you a IP address. Okay, offered your offered your IP address. What will be the broadcast IP address assigned to the smartphone? What is that? Received IP configurations from DHCP server. What will be the broadcast IP address assigned to the smartphone? So the broadcast IP address is not assigned to the smartphone. Broadcast IP address is assigned to the network. Okay, I think the wording is not correct. I think what the examiner is asking is the broadcast IP address of the subnetwork. Right? So what is the IP address of this subnetwork or the net ID? Because net ID is the smallest one. This one, right? /24. What I'm looking at this one because, and you can see others also has assigned 192.168.10.100. This is 10.1. This is 10.253. All are /24 because all are in the same subnet. So broadcast address is the biggest address. What is the biggest you can go? 192.168.10 and it's /24. So therefore, you have all these 8 bits. So the biggest you can go is 1, 2, 3, 4, 5, 6, 7, 8, right? And that will be the broadcast address because this network has /24. The smallest is 0, 0, 0, 0, 0, 0 subnet ID, right? Subnet ID and router is not assigned the subnet ID, rather the first IP address, 10.1, because 10.0 is the subnet ID. And broadcast ID is the biggest. So biggest is all 8 are ones. That is 1, 2, 3, 4, 5, 6, 7, 8. So what is that number? 1, 2, 4, 8, 16, 32, 64, 128, 256, 256 minus 1. This number must be 255, right? I'll go for 192.168.10.255. Right. I'll go for this because this is the biggest number in that IP range. Actually, broadcast address is IP address is not assigned to a particular machine. This word is not, very confusing. Basically, broadcast address is for the network. Okay. I'll go for D. Yes, answer is D. Anyway, the wordings are not very good. Right, 21. Right, 21 to 25 using the following information. Right, so these are set of questions. The machine in network L. Now this has nothing to do with the previous question because now that is done because it says this to 21, right? Here, 11 to 20. Now forget about this. Now concentrate on this only. So you have a network called L. Uh, it uses IP, a machine in that. In that network, maybe router is there, switch is there, there's a machine there, and it has 8.8.8.8/25. Okay. Your question is, what is the subnet mask Anyway, answers are bold here. I don't know why. I hope in the exams answers were not bold. Otherwise, students have the answers. Okay. So far it was not bold. All of a sudden it's bold, right? I don't know. Maybe that was not the case in exam. Right. What is the subnet mass? Anyway, it's a very easy question. If it is slash 25, that means 255, 255, 255, that is 24. But it's 25, then one, because 255 is because 8 ones. And 25 means another one. So then zeros. What is this number? 1, 2, 4, 8, 16, 32, 64, 128. So therefore this 120. So subnet mask is 255, 255, 255, 128. Right? So that is very basics. What is the maximum number of machines that can be connected to L? So this guy is just one machine, right? It's a super easy question. Now, if it's a 25 network means, so this part is available to you. This part is available to you. If you look at it as one network, because they have not asked you to create into sub-network, and it says it's one network. So therefore, how many bits for us to play around? 1, 2, 3, 4, 5, 6, 7. That is 2 to the power 7. But remember, two IP addresses are reserved. One for subnet ID, other one broadcast, minus 2. 2 to the power 7 is 2. 2 to the power 1 is 2, 4, 8, 16, 32, 64, 128. 128 minus 2, 126. Yes, 126 because you have 8 bits to 7 bits to play around. 2 to the power 7 minus 2. 23. What is the broadcast address of the network L? Right. So this is uh, because slash 25. But you can clearly see that this is 8. It is one of the IP address. It is one of the IP address. So therefore, it will be something like 8, 8, 8, 8. But I will just make this binary. 1, 2, 4, 8, 2, 3, 4. This is one of the IP address. This is one of the IP address, right? But remember it is slash 25, therefore this is the separation. And here this is one of the IP address. And the question is broadcast address. So broadcast address means, of course, we can't touch this 0 because we have flexibility after 25th bit. So therefore this cannot be changed. But broadcast address is all our ones. 1, 1, 1, 1, 1, 1, 1. That is 7 ones. 1, 2, 4, 8, 16, 32, 64, 120 minus 1, 127. 8, 8, 8, 127. Yes. Okay. If you know your subject, what is subnetting, right? I took a lot of time to explain subnetting. Again, go through the recordings if you have any doubts, especially subnetting, because you can see a lot of questions. Assume that the network L is divided into two equal size subnetworks, L1 and L2. Machine with the IP address 8.8.6.100 is in L2. Okay. I don't know why this is 6. It should have been 8, right? How come this is changed? I hope this is a mistake by the examiner. This should have been 88800, okay, because this is 8888. We can't change this octal when we have 25 slash 25. Okay. So I hope this should be 8, okay. What is the network address of L2? Right. So now we are going to, now remember we have this number of bits, 7 bit to play around because we got slash 25. But that is if you are going to create one network. Now they have decided to break it into two networks. Now you need to borrow 1 bit. Borrow 1 bit. So that is why I said 888, not 88. You can see they have fixed the issue in the answer, right? You can see 8, not 886, it must be 888. I think the examiner has given marks to all the students. You can see all are bold because of this mistake, right? Because of this mistake. Okay. But let's see whether they have given answer to. But anyway, let's calculate. We can calculate. Maybe the examiner has given marks because of these mistakes. 6, because you can see answers are not having 6. Because if it is started with 888, how can you go to 6 when we can only control the last octal, right? Anyway, we should be able to calculate this, right? Now we are going to break it into 2, right? So therefore, we need to borrow one more bit. So therefore, it will be 8.8.8. We need originally we had this, but now we are going to borrow another bit so that it can be 0 for one network and 1 for the other network, right? 1 for the other network, and this is 100. 100 is in which network? 100 is in because it must be related to this machine. This machine should it be here or here? Right. So that is what we need to check. Now here the biggest number value is, I'm looking at the biggest value, that is 0 and all ones. 1, 2, 3, 4. 1, 2, 3, 4. Here the biggest value is all 1. Then I can get idea whether this machine, assuming this is 8, okay? Whether this machine belong to first network or second network. Now what is this IP address? Uh, this is 0, okay? This is 0 because it says this is 8. Right? This is 8 because that is how we found that it is 0. Right? What is this number? The biggest in first subnetwork, biggest in second subnetwork. This is 1, 2, 4, 8, 16, 32, 64 minus 1, 61. So therefore, this IP address cannot be in that cannot be in that subnetwork. So definitely it must be here because that is 62 to the range. So therefore, the question is, what is the network address of L2? Right. So therefore, this guy must be belonging to second network. So therefore, its network address must be 0 is given to this, 1 is given to this. Network address must be all zeros. This is the network address of second part because this machine must be in the second part. So then it must be 1, 2, 4, 8, 16, 32, 64. 8.8.8.64. Do we have that answer? 88864. Yes, answer is there, but examiner has given full marks because of this issue, this 6, right? Because of that 6 issue, okay? Right. So therefore, answer should have been, if the question is properly asked with 8 here, B, because this machine is in the second network, second subnetwork, not the first subnetwork, okay? If it is not clear, you can ask, I can again explain, okay? Right. So the final question. Anyway, I have the others mark sheet එක මොනවද තියෙන්නේ 30 24. Yes, all are given marks. ඒ අර මෙතන ප්‍රශ්නයක් හරි. Because of this 6 issue. Right. Assume that the network L is divided into 4 equal size subnetworks. Now they are going to break it into 4 equal size subnetworks. Which one of the following is broadcast address of one of those subnetworks? Right. If they are going to break it into 4 parts, we are going to borrow 2 bits. Right. So then it will be 8.8.80 and 2 bits because 1 bit is not enough. Earlier, break it into 2 by taking only 1 bit, 0 and 1. Now you need to take 2 bits. So what are the possibilities? 0, 0, 0, 1, 1, 0, 1, 1. So then we get 4-bit patterns. 4-bit patterns. Now the question is, which one of the following is a broadcast address of one of the subnetwork? And remember, the subnet IDs are all zeros. Broadcast IDs are all one. So therefore, what we are interested in, broadcast IDs. So therefore, anyway, this is our subnet part. Then I'm interested in broadcast IDs. That is why I'm filling with ones. 1111. That is first broadcast ID, smallest IP address. This is the next broadcast ID. This is the next broadcast ID. And this is the next broadcast ID. Okay. Right. So let's see whether this one is there. 1, 2, 4, 8, 1, 2, 4, 8, 16, 32, 64 minus 1. That is 60. No. 1, 2, 3, 4, 5, 6, 7, 8. This is 1. This is 2. 1, 2, 4, 8, 16, 32. 1, 2, 4, 8, 16, 32, 64. 64 minus 1 is. Did I make a mistake? Three digits. 1, 2, 3. Ah, yes. Yes, sorry for that. Yeah, yeah. 1, 2, because the 0 is already there, right? Yes. So 1, 2, 3, we can have only one here. Sorry for that. Yes, that is why I'm not getting the correct answer. So I completely forget about that 0 because we only got /25 because the 0 is there. The 0 is there, right? Right. So therefore, this is 8.8.8. This part is binary. 8.8.8. This part is binary. 8.8.8, this part of binary, right? So therefore, what is this number? Anyway, this part is correct. I took all ones to make it broadcast. Right, this is 1, 2, 4, 8, 1, 2, 4, 8, 16, 32 minus 1 is 31. So this is an answer. Okay, 31. But let's see whether any other answer is there, but it can't be. What about this? 1, 2, 4, 1, 2, 4, 8, 16, 32, 64, 64 minus 1 is 63. No 63 answer. Nothing. What about this? 1, 2, 4, 8, 1, 2, 4, 8, 16, 32. 32 minus 1 is 31. So that is this one is 31, but this one is also there. 1, 2, 4, 1, 2, 4, 8, 16, 32, 64. That is 4 plus 1, 5, 95. 95 answer is also not there. And definitely this must not be there, right? Let's double check. 1, 2, 4, 8, 1, 2, 4, 8, 16, 32, 64, 64, 128 minus 1, 127. No, 127 is also not there. So therefore, this is the answer. This is the broadcast ID of the first subnetwork. Taking 0, 0. Other subnetwork 0, 1, 1, 0, 1, 1. Okay. Right. So if you know the theory, right, we did this in detail in the class, how to create subnetworks. Right. That's it. That's it about 2023 paper. Okay. Right. It took about 1 hour. Yes, you have 1 hour, but we discuss it. Right. We take a small break. After the break, we'll look at the 2022 paper. Right. Question number 1. Uh, a machine in a network L. This is one of the machine. Okay. One of the machine in the network called L. Right. One of the machine. It's user the network address 8.8.8.8 and its subnet mask is this, that is /24. 25 by 25 by 25 by 0 means /24. That means the separation is here. Okay, and this is one of the machine, right? What is the above subnet mask in CIDR notation? So obviously /24. Answer must be A. Just enter the number 24. Okay. A. Just give 1 minute, okay? Right, sorry for that. Okay. Right. Second one. What is the maximum number of machines that can be connected to L? So again, because it's 24, all 8 bits are with us. So therefore, we have 2 to the power 8, but 2 IP addresses are reserved. That is 248, 248, 16, 32, 64, 120, 256 minus 2, 254 machines. So we have 254 machines, 256 IP addresses, but 254 machines. So the answer must be C. Yes, answer is C. Third one. What is the broadcast address of the network? Right, so we have all 8 bits to play around. So therefore 11111111. Okay. That subnet ID is 0000000000. Of course, 8.8.8 and dot 8 is one of in this range. Okay. So the broadcast address must be 8888255 E. So these are easy questions, right? Third one, yes, E. Fourth one, assume that the network L is divided into 2 equal size subnetworks. So that means we are going to borrow one bit now. It's going to be /25 now. Okay. L1 and L2 so that we can take 0 for one, 1 for the other. Okay. What is the network address of L2? Because it's 8.8.8.0.123.123.4. Other subnet is 8.8.8.1.123.123.4. Right. And this is the subnet ID of the first subnetwork, 8880. What is the network address or subnet address of L2? That is 8881 and all zeros, because subnet ID is all zeros, broadcast ID is all ones. That will be 1, 2, 4, 8, 16, 32, 64, 128. Because 1 and 7 zeros is 128. So answer must be B. Fourth one is B. Fifth one. Right, 1 to 5. This is the last one for this. Assume that the network L is divided into 4 equal size subnetworks. Right, now it's 4 equal size. So that means we are going to borrow 2 bits now. 8.8.8.00.12345 other one 8.8.8.01.12345 likewise 10 and 10.12345 last one is 8.8.8.11 because those are the bit patterns available. Right, now the question, which one of the following needs a subnet mask? Okay, subnet mask. Subnet mask must be only one subnet mask. All these, that is, we separated by now this position. That is /26 888 24 26. 26 means 255 255 255, then 2 ones and 6 zeros. Those 1, 2, 3, 4, 5, 6. What is this number? For each subnetwork, you are going to have the same subnet mask. 1, 2, 4, 8, 16, 32, 64, and 128, 192. That is 255, 255, 255, because all are ones, and then 2 ones and 6 zeros, 192. For each and every subnetwork, you are going to have the same subnet mask because it's separated by 26 bit. Answer must be C. Yes, C. Right, now this is a different question. Right, what is the Hamming distance between, remember I did not do the Hamming port part. I told you that I will do it right? But I will do this in the next class, Hamming code, how to calculate the Hamming code. But this question is not calculating Hamming code, rather finding the Hamming distance. Okay. Let me open that note. I will only explain up to that point. Okay. Because I told you that I need to do small changes to the note, and after doing the changes, I will do Hamming code part. Actually, that is the only part we skip from your entire syllabus. Uh, Still, I have not added that full note, the full actually updated the note, but I have added the Hamming distance related part. Okay, so therefore, let me open that part. It was in link layer, right? No, physical layer. It must be physical layer, right? Yeah, it was in physical layer. Sorry, data link layer. Sorry. Right. So for this, you don't need to calculate the Hamming uh, code, rather you need to just calculate the Hamming distance. Okay. So remember, when it comes to data transmission, there are two things. One is data error detection. Other thing is error correction. So error detection is easier, but error correction means without asking to resend, you fix the error, which is more difficult. But in order to do that, the sender must send some additional bits. Additional bits. So Hamming code is sending additional bits so that in case simple errors, the receiver can fix it by itself without asking to resend. Okay. Right. I'm not going to explain how to calculate the Hamming code, but I'm going to explain what is Hamming distance is. Okay. Right. Hamming distance is very simple concept. Other part I will explain in the next class. Hamming distance is when we have two ports. Okay, let me open my pen. Right. So this is, assume this is what is sent, and this is what we received. So this is sent, what is sent, this is what we receive. Okay. Hamming distance is how many bits are corrupted or how many bits are altered. Simple as that. That is called Hamming distance of that code. Okay. Say if this is my original uh, data and this is my new received data, you can see this one is not changed. Zero is not changed. One has changed to zero. This is not changed. This one has changed to zero. These are not changed. So there are how many bits are changed? Two. So therefore Hamming distance is two. Simple as that. Okay, so this question is regarding that. Right? So then we have something called minimum Hamming distance. I will explain that also, though it is not required for this question. Right? So then only you can calculate the Hamming code and how to add Hamming code to your data. That I will explain in the next class. Right? But we can calculate the minimum Hamming distance. So minimum Hamming distance is, just listen to me very carefully. uh, Minimum Hamming distance of set of ports. Now these are the assume these are this example. These are possible set of ports. Forget about the zeros and this. This is because these BCDs. Zero is represented by four zeros. One is represented by 001. Two is represented by and so on. Okay, so therefore forget about these things. So therefore these are our possible codes, and it is 4 bit, 4 bits because 3 bits is not enough because from 3 bits we can create 2 to the power 3, 8, but we need 0 to 9. So therefore we need 4 bits in binary coded decimal. So therefore we have used these bit patterns, and we don't need the other bit patterns like 1010, 1011 because we just need 0 to 9. Say these are requirement. Okay. So therefore these are the possible bit patterns we are sending. So 000 means we are sending 0. 0001 means we are sending 1. 0010 means we are sending 2. And this is 9. And we are not sending other bit patterns because we are not interested in sending number other than 0 to 9 in BCD. This is just example, okay? Right now our task is if these are the codes, possible codes for these 4-bit situation, what is the minimum Hamming distance? What is the minimum Hamming distance? So minimum Hamming distance is smallest Hamming distance between all possible distinct codes. Right? Smallest Hamming distance between all possible distinct codes. Now, if you take, of course, there are so many possibilities, right? Between these two, these two, these two, these two, and so on. So then this one and between, say, this one and this one, this one and this one, this one and this one, or maybe something like this one and this one, or maybe first one and last one. Likewise, there are so many possibilities here. But if you look at some samples, you can get idea. For example, what is the Hamming distance between this one and this one? Hamming distance means which have how many characters, how many bits are changed. So these are not changed. Only this one is. So therefore, Hamming distance is 1. If you take those two, Hamming distance is 2 because 0 has become 1, 1 has become 0. If you look at these two, Hamming distance is 1 because these are not changed. Only this is changed, and so on. And if you take some random thing like this one and this one, how many changes? 0 has not changed, 1 has not changed, 0 has become 1, 1 has become 0 has become 1, Hamming distance is 2. So likewise, what we are interested in is not the smallest Hamming distance. Sorry, biggest, smallest. So therefore, obviously smallest Hamming distance is what? Like this to this or this to this. So that is called smallest Hamming distance. So that means between any two chords, what is the smallest Hamming distance? Out of the Hamming distances, what is it is the smallest we are looking at, right? Not biggest. That is called minimum Hamming distance. Right, that is enough. Accurate minimum Hamming distance is also not required for your questions from this paper, and the next year, previous year paper also there's this exact same question. Right. So then in the next class, I will explain basically what is how to calculate the Hamming code. Okay, because we never know they will ask that kind of question, but this is enough for these papers. Right, these papers. Right. So the question. So they have given you two codes. So they have given you two codes. This is my two codes. Question is Hamming distance. So it's even kids can answer this. Hamming distance is how many bits have been changed. This is not changed. This is not changed. This is not changed. This is not changed. This is changed. This is not changed. This is not changed. This is not changed. So only one is changed. Only one bit has changed, 1 to 0. So therefore, Hamming distance is 1. So how many bits have changed? Only one bit. Answer is C. Right? Even kids can do it. Okay. Right. Next question. 7. Which of the following is not a field in UDP header? Remember, UDP header has lesser fields because it's more for performance rather than reliability. Okay. But it must have the essential things like source port number, destination port number and so on, right? Those are must have, but you don't need additional things in UDP header. Okay, right? Destination MAC address. Do we need that? Right? Do we need the MAC address in UDP? Because UDP is between your two machines, and UDP is used when we are having different subnetworks. Right? So MAC address is not used outside subnetworks. MAC address is only within subnetwork. This is we are talking about communication of this machine with this machine. Maybe this is web server, this is your web client. So therefore, this we are not interested about the MAC address of this one. Actually, we don't have any idea about the MAC address. So therefore, definitely MAC address has nothing to do with the UDP or TCP headers. Obviously, we need the source port, destination port because we are going to create that connection. Right? Len, checksum, and so on. But when it comes to UDP level, right, basically MAC address is not visible to anything other than data link layer. Even network layer is only interested in IP address. So therefore, definitely answer must be not field is MAC address. A. Yes, A. 8. Which one of the following is not a TCP port number? Remember port numbers. I think port number is 16 bit. Right, 16 bit. That means 0 is the smallest. Uh, 16 ones, 16 ones is the next biggest. Right. So that means 2 to the power 16. I can't remember 2 to the power 16, but I can roughly remember it's something like 64,000 not 64,000 not because it's a 16-bit number. Okay, so what is 2 to the power 16? Just remember that value because it's a famous question. Right, 2 to the power 16. Right, 65,536. That means 65,535. Okay. So therefore, the question is not a TCP port number. Anything bigger than 65,000 cannot be a TCP port number. So these are all possible. This is also possible because less than 65,000, but this is 82,000 number. So therefore, answer must be C. Right? 8 answer is C. Yes. So we discussed that. Okay. So let's open our transport layer. Don't. Can see 65,536 is the biggest. 535. And they can even ask about this 0 to 1023 are well-known ports like 80 is HTTP, 443 is HTTPS, SMTP. I ask you to remember these things also. Then 1024 to 49,151 registered ports like MySQL port and so on. Uh, uh, then other than that, 49,000 to 65,000, about closer to 20,000 ports are private ports. You can use it for any purpose. Anyone can use these ports. Right? But these are the well-known ports. Right? Right. What is the range of values possible in the TCP checksum fields? Of course, that you can do only if you have remember the width of the TCP checksum. Right? TCP checksum. We discussed that. I don't know how feasible to remember these things. Okay. TCP field. TCP checksum. And this is a checksum. Do we have the size? Sequence number, acknowledgement number, control flags. Right, checksum. I have not given you the size, okay? Yeah, I have not given you the size of the checksum. Let's see whether UCSC note has given you the size of the checksum. Transport layer. Maybe that note has, because I can't remember exactly the size, right? How can we remember all these things? TCP checksum. This is UDP checksum, 8 byte. What about the TCP checksum? TCP we discuss after, but it's okay. So this is TCP. Remember, below 1024 is reserved. Checksum, checksum, checksum. 1 bit flags. I think UCSC note has also not mentioned it specifically, but they have asked that. Anyway, I can't remember exact value, right? Because that it's very unfair to ask that kind of questions, right? How can we remember all these things, right? But examiner has expected that you can remember, right? What is the answer? I don't know, right? I can't remember actually. Ninth one. Anyway, every paper has one or two this kind of question, right? Otherwise, students will get 100 out of 100 also, right? Right. So the examiner's answer, of course, not examiner's answer, then it should be 0 to 4095. Because, sorry, 0 to 65,000, because the answer is B, right? 9. Right. 9 answer is B. That is 0 to the 65. That means it must be 16 bit. Right. It must be 16 bit. Okay. 16 bit. Have they mentioned anywhere that it is 16 bit? Yeah, this is 32 bit, half of that, right? Yeah, half of that. Checksum is 16 bit, urgent pointer is 16 bit, window size is 16 bit, port is 16 bit, source port is 16 bit, destination port is 16 bit. 32 bit is sequence number and acknowledgement number and options and data. Those are 32 bit multiples. Uh, this means multiple of 32 bit, okay? But checksum, urgent pointer, source port, destination port, 16 bit. Okay, in TCP. Right, next question. A TCP connection experiences a packet loss when the congestion window is at 40 kilobyte. What is the value of the threshold after this packet loss? Remember, every time there's a packet loss, we discuss about the sawteeth, right? It reduce it to half. Reduce it to half. Okay, let me open that note. And transport layer. Right, easy. Right. So this is not the way to go. You break it into the zero and again keep increasing, but that is not efficient. So that is called slow start algorithm. But that is not practical. Okay, that is not practical. So the practical approach is like this. right? Instead of dropping the congestion window all the way down to zero, it set the congestion window at a new threshold or set to half of the value, right? So the new threshold is half, not taking it to zero and then increase. Okay. So that is called, sorry, sawtooth pattern. Sawtooth pattern. So if it got the error at 40th kilobyte, now you drop it to 20 kilobyte, not to zero. If you get that error at 80, you drop it to 40. If you get that error at 100, you drop it to 50. That is called fast recovery approach. That is a practical approach. This is called slow start approach. When you have issue, you drop it to zero and again try to increase. And again, when you get error, again drop it to zero. But that is not practical, right? That is not very productive. But this is much more productive. Remember, you drop it and again increase. And if this time it happens, say 36, then you drop it to 80, not 20. And again you try to increase. Because these are dynamic things. It depends on traffic situations and so on. So therefore you try to utilize it maximum. But when there's error, you again adjust. Okay. Right. So therefore 40 kilobyte is reduced to 20 kilobyte. The answer is C. Yes, answer is C. Okay. Because this is the practical approach. What is mean by marshalling? We discuss about marshalling and unmarshalling in two places. One is network topic, other one is enterprise application development, Java RMI. Therefore, you must be really master this, right? So remember, when you have remote method invocation, your client call the client stubs like a local call. Then client stub marshal it, the parameters and send it to the server. Server is again server skeleton. Sometimes we call it server stub also. Server stub get it and unmarshalling. This is where marshalling, this is unmarshalling. And after unmarshalling, give it to the server. So therefore, your client and server can think of it like a normal local calls because the network related things are handled by client stub and server skeletons. Okay, which can be generated using tools. So therefore, your code is much simple. So this is called marshalling. This is called unmarshalling. Okay, we marshal the parameters. Those are the value we send. Okay, right. What is mean by marshalling? Packing the parameters. Unpacking the it's yeah, packing the parameters, right? Marshalling is packing, unmarshalling is unpacking, right? Not unpacking. No, nothing to do with security, not pushing or pulling, nothing. Packing, unpacking. Packing means we convert it to a format where we can send it through the network, like serialization, because we are going to send it through the network as data packets. Okay. Here you need to unpack it so that your server can understand it. Right? Answer is 11. Sorry, answer is A. Right? A. Which of the following is step of remote procedure call RPC? Client calling the server stub. No. Client call the client stubs. Server calling the client stub. No. Server calls or the server stub call the server or server skeletons. The operating system passing the incoming packets to the server stub. Incoming packet to the server stub. Yes, right. Then the server stub give it to the server. But operating system. Okay, let's keep that for the time being. Client stub unpack the parameters. No, client stub pack the parameter, right? Server skeleton unpack or server stub. Server side, sometimes we call it stub, sometimes we call it skeleton. But client side, it is always called stubs. Operating system passing the incoming packet to the client stub. Incoming packet to the client stub. So usually operating system must give it to the server stubs, okay? And server stub call the server. I'll go for C. I think this is the better answer. It should be either C or E, but incoming parameters are not coming to the client, right? Client is the one who send it. I'll go for C. Yes, C. 13. What is the underlying protocol used in real-time transport protocol? Remember, real-time transport means you need to transmit it quick and fast, like data video streaming. If you are interested in speed or reliability, you always go for what? UDP, right? UDP, because you are interested in high speed. So answer must be A. In which layer of the following protocol stack real-time protocol plays? Right? Real-time protocol. Real-time protocol is also application layer protocol. Right? Just like, because that is streaming. Just like web is HTTP, email is SMTP, and IMAP POP file transfer is FTP. This is real-time protocol. Streaming. Uh, I'm not sure whether it's one or two, because this is socket interface. So this is basically your physical link network. No, this should be transport layer. Uh, I'm not very sure whether it's one or two, but one of those two. I'll go for one, taking it as an application layer. Okay. What is examiner's answer? Examiner has taken it as 2. B. That means examiner has taken that RTP is here. So then RTP is not in application layer, right? Because there's a layer above that. Okay, shall we ask ChatGPT, where is RTP? In which layer RTP belongs to? Yeah, it says application layer, right? Layer 7. If it is application layer, why not it is 1? But examiner has taken 2. Anyway, I'm not very sure about that. Okay. Why examiner has taken it as 2? Because ChatGPT says RTP is application. Just double check. Okay. Maybe ChatGPT is not correct. Just keep it that open, because I felt like 1, but examiner says B. Okay. Select the protocol which is not used in application layer protocol. Right, that is super easy. Obviously, TCP is not application layer, right? TCP is transport layer. All other HTTP is web. DNS, remember, very special application layer protocol. IMAP, SMTP, email. Right. What is the SSH port number? I asked you to memorize some port numbers. Right. I think I have given this in your note. Right. Under transport layer, some well-known port numbers. Like HTTP is 80, HTTPS, and so on. Yeah. This question is what? SSH. SSH is 22. 22. So the port number must be C. Yes, C. In a TCP connection, what happens when the sender's timer goes off before TCP acknowledgement received? So sender's timer goes off means timeout. If it is timeout, TCP is supposed to resend the data, right? At least few times. Because that is the whole purpose of TCP, right? Connection. Now you have sent it, but haven't got the acknowledgement. Then you resend it. Right? Resend it. Because we discussed that. Sender will retransmit. B. B. Yes. Okay. Let me check whether we have mentioned that in your note. Maybe our note. Have we discussed this? I think it must be mentioned somewhere. This is connection termination. Remember, we can wait for the acknowledgement. What happens if we do not get the acknowledgement? We need to resend. So this is toast. I don't think that it is mentioned in our note. I think I should add that also to there. Okay. Right. So we have discussed about marshalling and other things, but not this marshalling and marshalling. Okay. Yeah. So just remember that if you don't get the acknowledgement within the time frame which you have pre-configured, you need to resend it. Okay. Just keep that in mind. I think maybe it is mentioned in your UCSC note. Right. When there is a problem in the TCP connection, what is the TCP flag used to terminate the connection? Right. So obviously reset. Right. Not urgent, acknowledgement, push, or synchronize. Terminate is done by resetting. E. So we discussed that. Okay, this is a funny question, right? I don't know why examiner is asking this kind of a question. What is the file used in ARPANET? ARPANET built somewhere around 1969 uh, to list the computer names and their IP addresses. That is in good old days, 1960s and 70s. Uh, so they kept IP addresses so that they can route the data and blah, blah, blah. So they asked what was their file name, maybe historical thing, maybe examiner is interested in those historical thing. Uh, but I can't remember that. Okay. Maybe if you are interested in history of computer networking, history of internet, maybe you may have heard this. I can't remember the exact name. Okay. Uh, right. So the examiner's answer is D. Host.txt. Right. Host.txt. Just keep it in mind because examiner can ask it again. Right. 20. What is the tuple of the domain source record that define a protocol family? Right. Protocol families are defined by classes. Right. We discuss DNS records. Protocol families are defined by classes. Right. 20 E. Examiner has given marks to all. Why is that? Yeah. Examiner has given marks to all. But usually protocol family is determined by class. Maybe examiner thinks that it is too fussy. Okay. Remember we discussed about A record, triple A record, MX record. Okay. Right. Anyway, examiner has given marks to all the students. Which of the following organization is devoted to the further development of web? That is obvious W3C, World Wide Web Consortium. Right. 21 is easy question. C. C. 22. What is the correct statement regarding management plane of the switch architecture? Remember, management plane is interested in managing the network, software-defined architecture, software-defined networks. So you need to double check which one of these is a management task. Okay, management task. Packet buffering, packet scheduling, header modification, and forwarding. That is not management task. Consist of various ports are used for reception and transmission of packets. That is also not a management task. Keep the forwarding table updated. That is not management task. Contains the protocol responsible for managing the active topology of the network. At least the word managing is there. Contains the protocol responsible for managing the active topology. We'll keep maybe possibly this. Used by network administrators to configure and monitor the network. Right? Configure and monitor the network. Monitor is a management task. Right? So it's a little bit fuzzy now. This one also has the word managing, but it's more technical, right? Active topology. But monitoring, but again, configuring, is it a management task? I'm not very sure which one is the answer. Possibly D, or of course, obviously one answer is there. I don't know if the examiner will give marks to both D and E, or maybe one of these. I'm not very sure which one. I will randomly pick D or E. Okay. 22. Examiner has taken E. Configure and monitor the network. Make a note එක තියුණා හරි. note එක තියුණා. බලන්න note එක මේක තියෙන්න තියෙනවා හරි. Right, next one. Assume that there's a mininet network. Mininet is sort of a simulation network. I think by who is that? You American company competing with who are we? I can't remember. So that is their tool. Okay. Mininet network that has two hosts, H1 and H2, and one switch S1. That means H1 and H2 is connected to S1. So S1, H1 is and H2. These are computers, okay? Host. Connected to S1. What is the correct miniset command that can be used to check whether communication is possible between H1 to H2? So if you want to check the communication, basically you want to check ping, right? You do a ping command. Okay, ping command. But I can't remember exact format, but not test or something. Usually ping between H1 and H2. H2 ping H1, H1 ping H2, ping H1, H2. That I'm not very sure, but definitely it must be ping command. Okay, maybe ping H1 to H2. Okay, I don't think that there will be command like that. Usually, command come first, then the parameters, right? So that is how the usually command work. So therefore, I'll go for A because usually command do not come here, right? Usually command and then parameters. I'll go for A. I'm not very sure, okay? Because I haven't memorized it. That is a strange command because according to the answer, H1 ping H2. Maybe that is how the command is structured. I thought usually commands have command and the parameters, but this looks like a strange command. H1 ping H2. Okay. But you can always double check with ChatGPT. Okay. Maybe you can ask, list down the basic mini net commands because examiner might ask few more, right? List briefly or tabulate basic mininet commands because examiner can ask some other commands also. So just make a note of that. Do we have that ping? You can see H1 ping H2, right? H1 ping H2. So just make a note of this, okay? Some other commands. Sudo is, of course, if you want to get the admin power, that is not part of the. So this is how you start mininet. Okay. Then create a linear topology with three. This is just virtual thing. Tree topology. Right. This is one that they have asked. But just maybe you can have a look at few of other commands as well. Okay. At 24. What is the main component in DNS architecture which maintains a view of the entire network? Sorry, not DNS, defined networks. View of the entire network and implement the policy decisions. That must be very high level thing. Entire network and policy decisions. So usually those things are done by, okay, I can't remember. Is it northbound AP? That is software, right? View of entire network. Okay, I can't remember. Let's double check the note. Application layer, control layer. Then this is hardware. Application layer, different applications. Okay. Control layer, the brain of the SDN, manage how the underlying hardware handle traffic. Maintain the global view of the network. So the global view of the network is maintained by control layer. Okay, so then the infrastructure layer is your data layer, and so on, right? Yes, so the global view is maintained by control layer, right? Yes, control layer. Is it B? 24. Yes, B. Which layer of OSI reference model use segments as PDU? Remember, physical layer, protocol data unit is bit. Logical link layer, segment, right? Segment. Protocol data unit is, sorry, frame, right? Bit, frame, then network layer, data packet or datagram, then transport layer, it is segment. So therefore, segment is transport layer. That is layer 1, 2, 3, 4. Bits, data frame, data packet, segment. 1, 2, 3, 4. Fourth layer. D. Yes, that's it. And that's it about 2022 paper. Right. In our next another class, you have the regular class also. Regular class, we will concentrate on finishing the enterprise application development. We have two more topics. Those are very small topics. That is WebSocket and web services. That won't take more than 1 hour. And we are parallel doing the second papers also there. Therefore, we just need to do the MCQs. And next week also, I will, because now the semester 6 classes are over because they are having exams not this weekend, next weekend. So therefore, I can borrow their time slot, weekday slides time slots. So they use two slide time slots, Thursdays and Wednesdays and Thursdays. Now those two time slots I can take for you. So therefore, possibly more extra classes, maybe 1 or 2 extra classes next week, and we try to finish almost everything by next weekend, right? Next weekend, right? We'll stop at this point, right? So we'll do one more MCQ, and if there are any other second paper questions we have not done in our during our classes, okay? Right. We stop at this point.